In this question we are given a parabola y square is equal to 12x and we have to find the coordinate of the focus, the axis of the parabola, the equation of the directrix and the length of the lattice rectum. Let's begin with the solution. And the given equation of the parabola is y square is equal to 12x. Now as we can see, the given equation involves y square. So the axis of symmetry is along the x-axis. Also here we see that the coefficient of x here is positive, so the parabola opens to the right. Thus we have the coefficient of x is positive, so the parabola opens to the right. Therefore the parabola can be drawn. Now the standard form of a parabola which opens to the right and is symmetric along x-axis is given by y square is equal to 4ax, and the given equation is y square is equal to 12x. On comparing these two, we see that 4a is equal to 12. This implies that a is equal to 12 divided by 4, that is 3. Now we know that the focus of the parabola, which is symmetric along x-axis and opens to the right, is given by a0. Therefore the focus of the parabola is 3, 0. Next we have to find the axis of the parabola. Now we know that this parabola, which is symmetric along the x-axis and opens to the right, the axis of the parabola is y is equal to 0. Therefore here the axis of the parabola is y is equal to 0. Now we have to find the equation of the directrix, and we know that the equation of the directrix is given by x is equal to minus a. Therefore here the equation of the directrix is x is equal to minus 3, and now we have to find the length of the lattice rectum, and that is given by 4a. Therefore here the length of the lattice rectum is equal to 4a, that is 4 into 3, which is equal to 12. Thus the coordinate of the focus is 3, 0. The axis of the parabola is y is equal to 0. The equation of the directrix is x is equal to minus 3 and the length of the lattice rectum is 12. This completes the solution. In this question we are given a parabola x square is equal to 6y and we have to find the coordinate of the focus, the axis of the parabola, the equation of the directrix and the length of the lattice rectum. Let's begin with the solution. The equation of the parabola is x square is equal to 6y. Now as we can see, the given equation involves a term x square. Therefore the axis of symmetry is along the y-axis. So we can say that the equation involves x square, so the axis of symmetry is along the y-axis. Also from the equation we see that the coefficient of y, that is 6, here is positive, so the parabola opens upwards. Since we know that if the coefficient of y is positive in the equation of a parabola, which is symmetric along y-axis, the parabola will open upwards. Therefore, in this case also the parabola opens upwards. Now, the general form of the equation of a parabola which is symmetric along y-axis and which opens upward is x square is equal to 4ay, and the given equation is x square is equal to 6y. Now on comparing these two equations, we see that 4a is equal to 6. Therefore, we have a is equal to 3 upon 2. Now, we know that the focus of a parabola which is symmetric along y-axis and opens upward is given by 0a. Therefore, for the given parabola x square is equal to 6y, focus is 0, 3/2, and the axis of parabola, as we know, the axis of symmetry is along y-axis. Therefore, axis of parabola is, yes, x is equal to 0. Right? Now, we have to find the equation of the directrix, and we know that the equation of the directrix for this type of a parabola is y is equal to minus a. Therefore, here the equation of the directrix is y is equal to minus 3 upon 2, and finally we have to find the length of the lattice rectum, which is given by 4a, right? Therefore, in this case, the length of the lattice rectum is 4 into a, that is 3 upon 2. So this is equal to 6. Therefore, here the focus is 0, 3 upon 2. Axis of the parabola is x is equal to 0. The equation of the directrix is y is equal to minus 3 upon 2, and the length of the lattice rectum is 6. This completes the solution. In this question, we have to find the coordinates of the focus, the axis of the parabola, the equation of the directrix, and the length of the lattice rectum of the given parabola, which is y square is equal to minus 8x. Let's begin with the solution. And the given parabola is y square is equal to minus 8x, and here we can see that the given equation of the parabola involves y square. Therefore, we can say that the equation involves y square, so the axis of symmetry is along the x-axis. Also, the coefficient of x in the given equation is negative, which is minus 8. So the parabola opens to the left. And we know that the standard equation of the parabola, whose axis of symmetry is along the x-axis and which opens towards the left, is given by y square is equal to minus 4ax. So this is the general equation of the parabola. Now on comparing this standard equation with the given equation, which is y square is equal to minus 8x, we see that here minus 4a is equal to minus 8, which implies that the value of a is equal to 2. Now what we have to find? The coordinates of the focus, and for the parabola y square is equal to minus 4ax, the focus is given by minus a comma 0. So here the focus of the parabola is minus 2 comma 0. The axis of the parabola next we have to find, and we know that axis of parabola is y is equal to 0. Since the axis of symmetry is x-axis, therefore axis of parabola is y is equal to 0. Next we have to find the equation of the directrix, and equation of the directrix is given by x is equal to a. Therefore, here equation of directrix is x is equal to a and a is 2. So x is equal to 2 is the equation of the directrix. And the last thing we have to find is the length of the lattice rectum, which is given by 4a. Therefore, finally, length of the lattice rectum is equal to 4 multiplied by 2, and this is equal to 8. Hence, the focus is minus 2 comma 0. The axis of the parabola is y is equal to 0. Equation of the directrix is x is equal to 2, and the length of the lattice rectum is 8. This completes the solution. In this question, we are given a parabola x square is equal to minus 16y, and we have to find the coordinate of the focus, the axis of the parabola, the equation of the directrix, and the length of the lattice rectum. Let's begin with the solution. The given equation of the parabola is x square is equal to minus 16y. Now as we can see, the equation of the parabola involves x square. Therefore, the axis of symmetry is along the y-axis. Thus, we have the axis of symmetry along the y-axis since the equation involves x square. Also, we see that the coefficient of y in this case is negative. Therefore, the given parabola will open downwards. So we can write the coefficient of y is negative, so the parabola opens downwards. Now, the general form of a parabola which is symmetric along y-axis and which opens downward is given by x square is equal to minus 4ay. Now, on comparing this with the given parabola, we see here that minus 4a is equal to minus 16. This implies that a is equal to minus 16 divided by minus 4, which is equal to 4. Now, we know that for this parabola, the focus has coordinates 0, minus a. Therefore, for the given parabola, the focus is 0, minus 4. And since it is symmetric along the y-axis, therefore, the axis of the parabola is x is equal to 0 for both the parabolas, for the general form also and for the given equation. Now, the equation of the directrix is given by y is equal to a for this general form of a parabola. Therefore, in this case, the equation of the directrix is y is equal to a, that is y is equal to 4, and finally we have to find the length of the lattice rectum, which length of the lattice rectum for the given curve is 4a, which is 4 into 4, that is 16. Therefore, the focus has coordinates 0, -4. The axis of the parabola is x is equal to 0. The equation of the directrix is y is equal to 4, and the length of the lattice rectum is 16. So this completes the solution to the problem. In this question, we are given a parabola y square is equal to 10x. We have to find the coordinate of the focus, the axis of the parabola, the equation of the directrix, and the length of the lattice rectum. Let's begin with the solution. And the equation of the parabola is y square is equal to 10x. Now as we can see, the equation involves y square. Therefore, the parabola is symmetric along x-axis. Thus, this parabola is symmetric along x-axis, and also since the coefficient of x here is positive, therefore, the parabola opens to the right. Thus, we can write that the coefficient of x is positive in the given equation, so it opens towards the right. Now, the general form of the parabola, which is symmetric along x-axis and which opens to the right, is y square is equal to 4ax, and the given parabola is y square is equal to 10x. On comparing these two, we see that that 4a is equal to 10, or a is equal to 10 divided by 4, which is equal to 5 divided by 2. Now, we know that for this parabola, the focus is given by a, 0. Therefore, here the given parabola has the focus 5/2, 0. Now, the axis of the parabola for y square is equal to 4x is y is equal to 0. Therefore, this parabola is also symmetric to the x-axis and opens to the right. Therefore, in this case, the axis of the parabola is y is equal to 0. Now we have to find the equation of the directrix, and for this parabola we know that the equation of the directrix is x is equal to -a. Therefore, for the given parabola, the equation of the directrix is x is equal to -5/2. Finally, we have to find the length of the lattice rectum, and we know that for this parabola the length of the lattice rectum is 4a. Therefore, here the length of the lattice rectum is equal to 4 into a, that is 4 into 5/2, which is equal to 10. Therefore, the focus is 5/2, 0. The axis of the parabola is y is equal to 0. The equation of the directrix is x is equal to -5/2, and the length of the lattice rectum is 10. So this completes the solution to the problem. In this question, we are given a parabola x square is equal to minus 9y, and we have to find the coordinate of the focus, the axis of the parabola, the equation of the directrix, and the length of the lattice rectum. Let's begin with the solution. And the given equation of the parabola is x square is equal to minus 9y. Now as we can see, the given equation involves x square. Therefore, the axis of symmetry is along the y-axis. So we can write the equation involves x square. So the axis of symmetry is along the y-axis. Also, we can see that here the coefficient of y is negative. Therefore, the parabola opens downwards. So we can write the coefficient of y is negative. So the parabola opens downwards. Now, the standard equation of a parabola which is symmetric along y-axis and which opens downward is x square is equal to minus 4ay, and the given equation of the parabola is x square is equal to minus 9y. On comparing these two, we see that minus 4a is equal to minus 9, or a is equal to 9 divided by 4. Now, we know that for the standard form of the parabola, the focus is given by 0, minus a. Therefore, for the given parabola x square is equal to minus 9y, the focus is 0, minus 9 upon 4. The axis of the parabola is x is equal to 0. And the directrix is, for this standard form of the parabola which opens downward and is symmetric along y-axis, is given by y is equal to a. Therefore, here the directrix is y is equal to 9 upon 4. And finally, we have to find the lattice rectum, and we know that the lattice rectum is given by 4a. Therefore, for the given parabola, the length of the lattice rectum is 4a, that is 4 into 9 divided by 4, which is equal to 9. Hence, the focus is 0, minus 9 by 4. The axis of the parabola is x is equal to 0. The directrix is y is equal to 9 upon 4, and the length of the lattice rectum is 9. So this completes the solution. In this question, we have to find the equation of the parabola whose focus has coordinates 6, 0 and directrix is given by x is equal to minus 6. Let's begin with the solution. And here we are given a parabola whose focus has coordinates 6, 0 and directrix is x is equal to minus 6. Now, according to the given information, the focus is on the x-axis and the equation of directrix is parallel to the y-axis. Therefore, the given parabola is of the form y square is equal to 4ax, right? Now, since we are given that focus is 6, 0, and for this standard form of a parabola, focus is given by a, 0. So this implies that a is equal to 6. Also, as we know that the directrix of the standard form of a parabola is x is equal to minus a, right? And here minus a is minus 6. So a is equal to 6. Therefore, the value of a is 6. And thus we can say that the equation of the parabola is, substituting the value of a in the standard form of the equation of the parabola, we have y square is equal to 4 into 6 into x, which is equal to 24x. Therefore, our answer is y square is equal to 24x. So this is the equation of the parabola whose focus is at 6, 0 and directress is x is equal to -6. This completes the solution. In this question, we have to find the equation of the parabola that satisfies the condition that its focus is at the point 0, -3 and directress y is equal to 3. Let's begin with the solution. And here we are given a parabola whose focus has coordinates 0, -3 and directress is y is equal to 3. Thus, according to the given information, the focus is on the y-axis, which is on the negative side, and the directress is parallel to the x-axis. Therefore, the parabola will open downwards, and we know that the standard form of the parabola which opens downward or which has its directress parallel to the x-axis is given by x square is equal to -4ay. Now we know that for this parabola, the focus is 0, -a. Therefore, and we are given that here in this case the focus is 0, -3. So on comparing the focuses, we see that a is equal to 3. Also, for this standard form of the parabola, the equation of the directress is y is equal to a, and here on comparing the given directress with the standard form of the equation which has the directress y is equal to a, we see that a is equal to 3, right? Therefore, the value of a is equal to 3, and we can say that the equation of the parabola is substituting the value of a here, we have x square is equal to -4 into 3 into y, or x square is equal to -12y. Therefore, the equation of the parabola whose focus is 0, -3 and directress is y is equal to 3 is x square is equal to -12y. This completes the solution. In this question, we have to find the equation of the parabola whose vertex is at the point 0, 0 and the focus has coordinates 3, 0. Let's begin with the solution. And here we are given a parabola whose vertex is 0, 0 and focus is 3, 0. That is, this point 3, 0 lies on the x-axis, and therefore the parabola is open toward the right, and we know that for this type of a parabola, the standard form of the equation is y square is equal to 4ax, and for this parabola the focus is given by a, 0. Now here we are given that focus has coordinates 3, 0. So on comparing these two, we see here that a is equal to 3. Therefore, substituting the value of a in this equation, we will get the equation of the parabola. Therefore, the equation of the parabola whose vertex is at the point 0, 0 and focus is 3, 0 is y square is equal to 4 into 3 into x, which is equal to 12x. Therefore, we have y square is equal to 12x. So, this is the required equation of the parabola. This completes the solution. In this question, we have to find the equation of the parabola which satisfies the given condition, and the condition is that the equation of the parabola has vertex 0, 0 and focus as coordinates -2 and 0. Let's begin with the solution. And here we are given a parabola with vertex at the point 0, 0 and focus as coordinates -2, 0. Now let us see where the focus -2, 0 lie on the Cartesian plane. Now on the x-axis towards the negative side lie the point -2, 0. Therefore, the parabola will open towards the left and the axis of symmetry will be along the x-axis. Suppose this is the parabola, then the standard form of the equation of a parabola whose axis of symmetry is x-axis is y square is equal to -4ax, since we are given that the focus has coordinates -2 and 0. And for this parabola, the focus is -a, 0, and on comparing this focus with the given focus, we see that a is equal to 2. Therefore, substituting a is equal to 2 in the standard form of the equation of a parabola. Now substituting a is equal to 2 in y square is equal to -4ax, we get y square is equal to -4 times of 2 into x, which is equal to -8x. Therefore, the required equation of the parabola is y square is equal to -8x. This completes the solution. In this question, we have to find the equation of the parabola that satisfies the given condition. It says that the vertex of the parabola has coordinates 0, 0 and the parabola is passing through the point 2, 3 and the axis is along x-axis. Let's begin with the solution. And we are given a parabola with vertex 0, 0 and passing through the point 2, 3, and also we are given that the axis of the parabola is along the x-axis. Therefore, the parabola will either be towards the right or towards the left. That is, either it will open towards the right or towards the left, but since it is passing through the point 2, 3, which is somewhere lying here, so the parabola is opening towards the right. Suppose this is the parabola, and we know that for this type of a parabola, the standard form of the equation is y square is equal to 4ax. Now since the point 2, 3 is on the parabola, that is, the parabola passes through the given point having coordinates 2, 3. Therefore, this point will satisfy the equation, that is, replacing y by 3 and x by 2, we have 3 square is equal to 4a into 2, which implies that 4a is equal to 9 divided by 2, or a is equal to 9 divided by 8. Now, substituting this value of a in the standard form of the equation, therefore, on substituting, we get 4 into 9 divided by 8 into x. Now 4 2s are 8. So we have 9 upon 2x. Therefore, y square is equal to 9 upon 2x, or this can be written as 2y square is equal to 9x. Therefore, the equation of the parabola is y square is equal to 9x. This completes the solution. In this question, we have to find the equation of the parabola that satisfies the given condition, and the condition is that the vertex of the parabola is 0, 0 and the parabola is passing through the point 5, 2 and is symmetric with respect to the y-axis. Let's begin with the solution. And here we are given a parabola with vertex 0, 0 and passing through the point 5, 2 and is symmetric along the y-axis. Now, the given parabola, therefore, the parabola will be upwards or downward opening. But since the parabola is passing through the point 5, 2, which is somewhere here, therefore, the parabola will be opening upwards. And we know that the standard form of this type of a parabola is given by x square is equal to 4ay. So let x square is equal to 4ay be the required parabola. Now, this parabola passes through the point 5, 2. Now, the question further says that the parabola passes through the point 5, 2. Therefore, this point satisfies the equation x square is equal to 4ay. Therefore, replacing x by 5 and y by 2 in the equation, we can get a is equal to 25 divided by 8. Now, substituting the value of a in the equation x square is equal to 4ay, we will get the required equation of the parabola. So we have x square is equal to 4 into 25 divided by 8 into y, which on cross multiplying implies 2x square is equal to 25y. Therefore, the required equation of the parabola is (2x square is equal to 25y). This completes the solution.